Welcome to the Frontier Founders Podcast. This is episode 1, and today we're here with Blake Scholl, founder and CEO of Boom Supersonic. Hi, I'm Phil Liang. I'm an entrepreneur and investor, and today we're here with Blake Scholl, the founder and CEO of Boom Supersonic. Thank you for having us.
Thanks for being here, Phil. It's a really exciting time here in the Mojave Desert, as we are literally days away from flying XB1 for the first time.
Yeah, so for our listeners, just a heads up, we're right now in the hangar where XB1 is. It's an extremely windy day. We've got a blooper reel of some tumbleweeds basically pushing a door open to kind of illustrate just how windy it is. So we apologize in advance for all the noise. And on top of that, we've got some Boom engineers currently working on the XB1, which we didn't want to stop at work since they're potentially just days away from their first flight. Let's first start about the journey of Boom. Obviously, this is incredibly ambitious to build a whole new aircraft company from scratch and to build the first plane being a supersonic plane. And you said to me that this is basically a decade-long journey.
I actually have been working on this for a decade, and there's probably the better part of a decade to go before we realize the very first part of our vision. But my, a little bit of my story. My kids had a grandfather who lived in Hong Kong. Their mom grew up in Hong Kong, and it's 18 hours today from Denver to Hong Kong, and it's just too long, especially for the very young or the very old. And the result was my kids got to meet their grandfather maybe 3 or 4 times their entire life before he passed during COVID, and it's incredibly tragic. Had that flight been half as long, it wouldn't have been 3 or 4 times. It'd have been probably 30 or 40. Because it's so very different to have a shorter flight. People go way more often when flights are faster, and that would have made a difference in generational connection for my kids. And I find it infuriating because the airplanes we have today are no faster than the ones we have when my parents were growing up. And it holds back human connection across distances. At this point, going on kind of 2 generations of no progress in the basic thing an airplane is for, which is getting you from point A to point B in a way that you couldn't go otherwise. This is something I've been passionate about for a very, very long time. In my mid-20s, I set a lifetime goal of flying supersonic, and I put a Google alert on supersonic jet because I wanted to be first to know when I could buy a ticket. And for the better part of a decade, it was just crickets. There was no credible effort to pick up where Concorde had left off and to build a new generation supersonic jet that would bring the capability of high-speed flight to more people. There's some talk of supersonic private jets that were going to be for even smaller number of people. Nothing that was really going forward. Meanwhile, I had my first career doing internet stuff. Founded a company, sold it to Groupon. And I left Groupon thinking, why am I here, on Earth? And wanting to work on the most important thing that wasn't impossible. And so I thought, okay, Blake, I got to look at this supersonic travel thing. There's probably a good reason nobody's doing it. I'll want to understand that for myself. I'll get it out of my system, and I'll move on. What it really took was only about 2 weeks of research to realize that a lot of the claims that were made about why supersonic transport couldn't work didn't stand up to careful analysis that anybody with a spreadsheet and a web browser could do. And so that was 2014. My first journal entry was almost exactly 10 years ago. And the vision that we had back then is basically the same vision we have today, that we want to have a lot more in-person interaction. And to do that, we need flights that are not just faster, but also more affordable, more convenient, really focus on how do you get people from point A to point B in the fastest, most convenient way. So I spent about a year basically just learning aerospace, took an airplane design class, built a spreadsheet model of the airplane before we started hiring our first people. And one of the very early decisions was really around, okay, what does a practical path to success on an ambitious mission like this look like? And I would I tried to take my own ego out of it and said, okay, great. Imagine it's the year 2050 and I'm sitting on the beach sipping Mai Tais. And I'm reading the history books about how the world made the leap to supersonic. Does it say, after 150 years of not doing it, Boeing finally did it? That's not plausible. That's not how these things go. It's not like big companies don't just not do anything and then suddenly do something. So, okay, it's going to have to be a new entrant. And what would the new entrant be like? Well, they're not going to be steeped in all the conventional wisdom of why this is impossible. It's going to have to be somebody from outside of the industry who is willing to break from conventional wisdom. And what would that effort have to look like? Well, they'd have to have a dream team, because this is technically hard. They have to be incredibly perseverant, incredibly resilient, because it's going to be a long and challenging path. They have to be incredibly persuasive, because they need to bring along customers, airlines, suppliers, get people, investors, get people to buy into the vision and the importance of this, years before it's going to come to fruition. And then they would have to have tangible proof points along the way that would cause people to have belief that the effort was going to actually succeed. And so it's sort of like I can sort of imagine that this is how history would kind of have to go based on everything we know about the history of innovation and entrepreneurship. I said, okay, great. Well, let's go become that. And so one of the early decisions was, rather than do kind of a big bang, let's go build a 400,000-pound safety critical supersonic airliner as the very first thing we do as a company, let's go sketch that out, and then let's go do kind of the same thing that SpaceX did. Let's build a subscale vehicle that we're going to learn a lot from. And that's what the airplane behind me is. We took our initial design for Overture, we shrank it down, and we said, let's go design, build, learn. And knowing that the way we'd approach Overture was going to evolve from everything we learned. And so XB1 was sort of born as the first independently developed supersonic jet, the first one ever to be made outside of a government or military. And again, very parallel to the Roadster at Tesla or the Falcon 1 at SpaceX. And so it took from founding to first flight, about a decade. And then that's allowed us to go launch into the Overture effort, which is our all business class supersonic airliner that you can think of as a scale up of everything we've learned on XB1. And that's also probably a decade effort that we're about 3 years into.
It's truly incredible what you made. And in full disclosure, look, I'm an investor in the company, and early on, when I first, a friend referred me to you, the shocking part was I thought that Boom, frankly, wasn't real. And that's because right now in the press, that what you read about is, okay, you had engine issues, you had this. But when I dove in, I was like, one of the things that surprised me when doing diligence with you is I quickly determined this is quite the opposite. It's you've actually got a team that you constructed who built planes, probably the only team, at least in North America, that's actually built planes recently, at least in the US. Mm-hmm. And you probably got the cream of the crop. I mean, how did you go from nothing to being able to build that?
I think all the way back to day zero, I didn't know anybody in the industry, and my first meeting in the industry was somebody who had worked for me at Groupon, had played hockey in college with somebody who now worked at SpaceX. And so I flew down to SpaceX headquarters in a little airplane that I could fly, which is really the only cred I had in aviation, is I could fly a little airplane. And I met this person, and I said, okay, if you could get anybody in the world to come explain the vision of what we're doing and why I thought it was practical. I said, if you get anybody in the world to come and work with you on this, who would be your top 5? And he gave me 5 names, and I met those 5 people, and I asked them the same question. And there's the whole 6 degrees to Kevin Bacon thing. Turns out there's also 6 degrees to the best engineers in the world. And when you tell people you're building a supersonic airliner, the first question they have, they don't always say it out loud, but I could tell it was the question they really had was, are you crazy? And if I could convince them that maybe the answer was no, maybe this actually made some sense, maybe it was actually practical, then their second question is, how can I help? And it is really the dream of any engineer that goes into aviation, doing something like building a supersonic airliner that their friends and family and loved ones can fly on. That's the big dream. Inside the company, the thing that really makes this work is from the engineer designing the airplane to the janitor, everybody wants supersonic flight. That's why they're all there, and they're incredibly committed to it. And we have enormous obstacles ahead of us, and we also have enormous obstacles that we've already overcome. The thing that enables it to work is the quality of the team and that resilience in the face of challenge.
Obviously, you've faced many challenges. Mm-hmm. Which of those challenges would you say was the most difficult? I mean, which ones made you say, okay, I don't think I can do this. I'm just going to pack my bags up and run. I'm sure you've had many of those moments, because the reality of entrepreneurship is it's never a straight line to success.
On day zero, I thought it was just highly likely that we would fail. I'd look in the mirror and like, I didn't have the resume for this. I imagined like, what is the successful founder, CEO of a supersonic airliner company? And I look in the mirror, like I'm the internet guy that, built a barcode scanning game. And so I very much had this idea of like, okay, my job is to go become that person. And my job is to turn Boom into the company that does it. There's enormous challenges that we've had to overcome from getting the airplane design to work. And there's the technical stuff, like how do you build a jet that goes really fast but also can take off and land stably and safely? How do you get it to be quiet enough that it'll be friendly to airport commuters? All kinds of technical challenges. There's all kinds of, how do you build a super high tolerance airplane? How do you set up a composites manufacturing capability, et cetera, et cetera? The hardest stuff has all been getting the team and the company and the culture together, because we're building a startup in an industry that has not had a startup for 100 years. Like the last new entrepreneurially founded commercial aircraft company was Douglas Aircraft in 1921. And so we have to not just hire great technical people, but we have to hire great technical people and then get them to understand what a 21st century aviation startup actually needs to look like, how it needs to operate. And that stuff has been incredibly challenging to iterate on the culture and getting that right.
So speaking of that, isn't one of the greatest challenges, looking at Boeing, looking at Airbus, the last time they had a brand new airframe program basically was 2004 for the 787 and for the A350. But they haven't announced any new programs since then. So basically, it's been decades. It's been 2 decades since they've actually had a new aircraft program. Do they still have knowledge, and do they know how to build a new plane?
I think it's a really astute question, Phil. If we look at everything that's been learned in tech about how do you build new companies and how do you build new products, like the theme is iteration, iteration, iteration. How do we shorten the cycles from trying something to understanding whether it works, and then folding that back into whether it's product or technical. And in aviation, the cycles have just gotten longer and longer and longer. And like Boeing's last all-new airliner was the 787, which was formally launched in 2004, and then the current CEO of Boeing has said that he's promised that he will not do that again until 2030 at the earliest. And so I think that's 26 years. That's a whole generation to go by without a new product. Just think about what that does to the team. It means it means your entire career you might see 1 or 2 new programs. Is the best case scenario. The learnings get lost easily. So I think that makes it incredibly difficult. And the feedback loops are that I believe like long cycles beget long cycles and short cycles beget short cycles. So if you might only get to see 1 new program or 2 new programs in your life, the first one you're so young you don't have any influence. By the time you're on the second one, it's the last one you're ever going to see. And so now you got to put all the bells and whistles into it, which by the way makes it fat and bloated, now pushes the cycles out even further. Part of what we want to do is move the industry in the opposite direction, to really speed up the rate of product development and to ship airplanes a lot more quickly and to be able to more agilely make improvements. And so that's part of why we started subscale with XB1. And there's a whole, our first airplane we call Overture, which is an all-business class supersonic airliner. But there's a whole product roadmap behind that. There will be an Overture 1.1, Overture 1.2, and then there'll be a big leap with an Overture 2, and so forth. And what we want to do is really shorten those development cycles, because that's how we will ultimately deliver more value faster. That's also how the team learns. Like we have the only living team that has built a supersonic civil aircraft. Like there's some of the Concorde team that's still around, but certainly not. They're all retired at this point. And I think that's a hugely valuable, incredibly difficult to replicate asset. And the more programs that team goes through, the stronger they get.
That's great. Can you talk to us about the steps of a program? The first phase, I assume, is XB1, is getting that to fly. The next is the Iron Bird, which would be great if you could describe what that is. And then next basically comes a plane and then flying it.
I could talk about how airplane design kind of works, and then how a lot of that iceberg is kind of underneath the surface. So maybe I could explain that a little bit, and then connect it back to the things you can see above the surface level. So there's, again, I'll contrast it with the software world. In the software world, great products are very loosely coupled. Like if you've got a complex piece of software, if you change this part over here, it really shouldn't affect how this part over here behaves. But that's not true of airplanes. At least well-optimized airplanes are incredibly tightly integrated. The design of every piece affects the design of every other piece. So for example, if we say we want to add a couple more passengers, now the fuselage needs to get bigger and it's heavier, so then the wing needs to get bigger and heavier, and the engines will need to get a little bit stronger to be able to carry it, and that means it's going to need more fuel. The fuel goes in the wings, now the wing's a little bit bigger too, and this whole thing spirals. So one of the things that we put a lot of investment into at Boom is building great digital design tools that allow us to, in simulation, iterate far faster. We have a tool called Make Boom, where you can basically put the definition of an airplane, like literally in a config file, and press a button, and you can have a quick and dirty answer of how well that airplane concept performs in seconds. And overnight, you can have a pretty high fidelity answer of how it performs. And if we learn something new, about say engine performance or how efficiently we can design the structure of a wing, then we can press a button again and like get a refreshed answer very, very quickly. And so that all supports what is sort of a spiral approach to design, where the early phase, and actually the most important phase, is really just laying out what the airplane is. You know, how big is the fuselage? What shape are the wings? How many engines of what kind? Of what power and where? Once that's locked, and that's where 80% of the destiny of the airplane is locked at that point. And then you start designing. Okay, well, where exactly are all the nuts and bolts and wires and and then you get into hardware. And our philosophy is get to hardware validation quickly. And so on XB1, every single component was tested before the airplane was ever assembled. We built a test wing spar, took it all the way to the point that it broke. And we tested it to the highest loads it would ever get. We ran every other system on the airplane we ran on the ground before it ever got integrated. And so now fast forward to Overture. Big investment in making sure we've got the airplane concept exactly where it should be. And then as we go into development, we're doing that same hardware in the loop testing approach. And that's where we have something called an Iron Bird. If you think of an airplane as analogous to a human body, the Iron Bird is the entire body minus the skin and minus the bones. So it's got the circulatory system and the nervous system and the lungs and the muscles. And that's what the Iron Bird is. It's about a 70,000 square foot facility where literally we'll have moving landing gear, we'll have moving flight controls, we'll have the electronics, the avionics, the hydraulic system, everything really except the skin of the airplane and the flying structure. What that lets us do is debug everything while everything is easy to get to and easy to change. And so we'll have taken that airplane through a zillion flight scenarios, normal scenarios, as well as emergency scenarios that you would never deliberately do in the air. You can do them on the ground in simulation with hardware in the loop. And then that will enable us to go move forward into building overtures with a lot of confidence for that first flight all the way into production.
I think one of the big questions right now is we see all the issues that's happening with Boeing. What can you learn at Boom from the mistakes that they've made to make sure that it doesn't happen with Overture?
If we look at like some of the very specific things that were done on the Max, for example, like letting a single sensor have so much control over the airplane, it's easy to laugh at it and say like, that's really stupid. We're smart. We wouldn't do a stupid thing. But I think it's really important not to take that perspective and to have a lot more humility. Somehow a group of people did something that no individual would ever do. And I think that's a pointer to why culture is so important. And a safety culture, quality culture it's really hard to build, and it can be broken in an instant. And that's where you lose the trust of your team. It's where you lose the trust of your regulator. It's super important to build it. And I think of it as this like precious little flame that we have to really protect and carry forward, and it's a big piece of my job to make sure we've got that right, and not to be arrogant. Like groups of people can do things that no individual would do, and so we've put a lot of energy into our safety culture. And for example, I talk about it regularly at all hands. As if people don't hear it from me over and over again that this matters, they will implicitly get the message that it doesn't matter. We teach the entire company to think at a long time horizon. If you think at a short time horizon, if you think of the next quarter, like, is it going to be better to cut a corner or is it going to be better to do it right? It's difficult. If you think in a 10-year horizon or a multi-decade horizon, the answer is obvious. Like long-term financial success and building a quality product are 100% aligned. And so that long time horizon and getting the team to think with a long time horizon matters. And then building a culture where people talk openly about quality and safety issues is important. Like every program is going to have problems. There's going to be challenges. The question is whether you put them out in the open and you face them and you deal with them and you learn from them, and then you fix them and you fix the root cause, and you fix the root cause in a way that it stays fixed. That's what you have to do. And so, for example, on XB1, the team has a daily stand-up meeting, 7 a.m. every day, 6 days a week. And the crew chief gets in front of the entire team. All the engineers are there, the manufacturing people are there, the techs are there, the pilots are there, program people are there. And the very first question the crew chief says is, who would like to talk about quality and safety issues we had yesterday? And the entire team is thrown open to it. And most days there's nothing to talk about. Some days there are. And one of the things that I'm most proud of is people will get up and they'll say, I made a mistake yesterday. Let me tell you what it was and what I learned from it. And then we reward that. And so we encourage talking about issues openly where we can deal with them, resolve them, fix them. And we also, as a backup, we have an anonymous safety reporting system that's patterned off of what NASA has done that was a real good thing for generating learning in commercial aviation. And so we have an internal anonymous safety reporting system. And what we found was the more we worked on our safety culture, the less we saw people use the anonymous system because they didn't need it. They just talk about it. And and as we lead up to, over the next, few days, getting this airplane in the air, what I tell the team is, this is where we really earn what we've worked on for the last 10 years, not just in flying the airplane, but more importantly in our culture. Like I stood in front of the team this morning and I said, we all want to go. Airplane wants to go. We're itching to go. If there's something not right, we got to not go. And we want to know about it. You find something wrong on the airplane, bring it up. We'll deal with it. If it delays us, we'll deal with it. We want to go. But we got to be ready to go. Let's make for damn sure we're ready to go.
Can you tell us a bit more about XB1? Like how quick is it going to go?
Yeah.
How much you're going to learn about it?
Yeah.
The specs. I mean, it's a beautiful looking plane. The scale of it's absolutely incredible. The proportions are stunning.
It surprises people when they walk in the hangar how significant this airplane is. It's 70 feet long. It's a 20-foot wingspan. And so it's much larger than a typical fighter jet actually. And so if you're in the hangar here, we have an Air Force fighter trainer sitting next to XB1, and you look at him and you realize just how much more substantial XB1 is. The mission of XB1 is really for us to learn the lessons and demonstrate the key technologies that make Overture possible. And it was originally designed to go Mach 2.2. Which was the original design speed of Overture. As we learned about where the breakpoints are in being able to be fast enough for passengers versus where the efficiency breakpoints are, technically we actually backed off on that a little bit. So the target speed for Overture is Mach 1.7. And but at that point, XB1 was already built, so it's got a Mach 2.2 airframe. And how fast will we actually fly it? We haven't decided yet. But we will take it supersonic, comfortably so, and then we'll kind of look and say, hey, is there further learning to be had there with more speed?
Can you tell us a bit about where Boom is today as a company? I mean, I know you've got a factory, but I think people would love to learn about everything that you guys have created. The
company overall is approaching 300 people. And we have one team kind of finishing up XB1. We have another team, another larger team actually working ahead on Overture on finishing that design, also building out the supply chain. We've probably signed up on the order of 3/4 of the key suppliers that are going to build parts for Overture, and these are the same suppliers, the best in breed suppliers that build parts for Boeing and Airbus. So, Leonardo has the lead on the fuselage. They do the 787 center fuselage. Honeywell is doing our cockpit avionics, flight deck. Latticor is doing our wiring. Safran is building the landing gear. And these aren't necessarily all household names, but these are the same companies that build the critical parts on the airplanes that we all fly on. And so that effort is moving forward. We expect, roughly mid-year, we're going to go pencils down on the Overture design, and then we're going to invite all of our suppliers to come to our headquarters in Denver and work together on the more detailed development of the airplane. And at the same time, we're standing up the manufacturing capabilities. So we have a 180,000 square foot facility in North Carolina in Greensboro, North Carolina, that we call the Super Factory, that we broke ground on a little over a year ago, and we are now just a few months away from officially opening. And that's part of an overall 62-acre campus that will house assembly line number 1, assembly line number 2, other test facilities, the completions and delivery center in Greensboro, North Carolina.
I think one thing that most people understand is that typically you have the airframe manufacturer and then you have the engine manufacturer. So when you buy Boeing, you sometimes have a choice, sometimes you don't, but you can go with Pratt & Whitney, you can go with your Rolls-Royces. In your case, there was a lot in the press about Boom, the challenges of selecting an engine supplier, but you guys ended up with an innovative solution. How hard was that? Can you talk about that process and what happened there?
Yeah, so the long story short, we're doing what SpaceX does. We're doing what basically every successful new entrant in aerospace does, which is we're vertically integrating propulsion. And so we have an engine we call Symphony, which it's a Boom-developed engine that is customized for what Overture needs. And we own all the intellectual property on that. And what we're finding is we get a better engine faster and cheaper versus if we went to an outsourced engine company and said, build us an engine. And to give a little bit of the history on this, I think we knew from day one that we would ultimately vertically integrate propulsion at Boom. In fact, for that reason, our very first employee was a propulsion engineer. And as we went along, we wanted, our overall philosophy was kind of least risk into full-scale manufacturing. And so if we could take a subsonic engine and adapt it for supersonic and get there faster and cheaper, we wanted to look at that option. And we very publicly dated with Rolls-Royce, and we sort of looked at what would it take to take one of their engines, adapt it for supersonic flight, and it's doable. But as we looked at it in detail, both economically and technically, there were some really meaningful drawbacks. A subsonic engine is designed to run at full power only for a few minutes at takeoff, and then it's kind of hanging out at cruise at a much reduced power setting. Versus a supersonic engine needs to be the exact opposite. It actually doesn't need all of its power for takeoff, but it's full power, for multiple hours in supersonic cruise. And for that reason, the way you tune it for reliability, if you get to change everything, is very different. And so a subsonic engine on a supersonic airplane can work, but it's going to be a lot less reliable. And we looked at one point, and literally 40% of the cost of supersonic flight, 40% of the cost of a ticket, was going to be engine spare parts. And we looked at it and we said, that just doesn't make sense. There's got to be a better way. And so we went and we hired our own engine design team, and we said, if we're willing to go roll our own, what can we get? And what we found was we could get something much better, faster, and cheaper if we were willing to fully customize. And to put this in practical terms, with Symphony versus a shoehorned engine, literally the fares that passengers will have to pay for tickets will be hundreds of dollars lower. Makes an enormous difference in the affordability of supersonic flight. It makes an enormous difference in the profitability for our airline customers. And then when we find that when we own and control our own destiny, we actually move faster at lower expense. And and a lot of people ask questions about this because in today's world, there are some companies that make airplanes, and there's some companies that make engines and then they kind of hang them under the wing. But if you look at the new entrants, that's not the path that has really ever led to success.
So obviously this requires a massive amount of capital, and it's going to require an additional amount of capital in order to get you to commercialization. Can you talk about your plans of how you've managed to get this far so far, and some of your future plans?
Yeah, I mean, in my view, we're already well into commercialization. We've got 130 aircraft ordered or pre-ordered from airlines, including United, American, Japan Airlines, and in the case of American and United, they've already made non-refundable deposits. And so the art of doing something capital intensive comes down to a few things. One is you got to prove that your technology really works, and that's what this airplane is about. You got to prove the market is really there, and that it wants very specifically the product that we're building. And that's why the orders with deposits from meaningful airlines is really significant to the overall story. Because there are a zillion different theoretically buildable supersonic airliners, and we need to make very specific choices about how fast and how many passengers and how much range and what fuel efficiency And all of those things are trade-offs. And so making sure that we've got customers that want very specifically the airplane that we're building is really important. And then if I bring it back to financing, we've known from day one this is going to be a capital-intensive effort. So that means the market's got to be really large in relation to the capital. And we've looked at this a lot of different ways, but we see a market for over 1,000 overtures, which takes us well into the hundreds of billions of dollars in market opportunity. So something that's going to take 6 to 8 billion to develop over time. It creates a smart return on investment scenario. So the art is to leverage the investor dollars. So the investors provide, in some ways, the foundational capital, but then we lever that up with government dollars. We're very grateful to North Carolina, which put together a really significant package to fund the super factory. And they did it because we're going to bring a lot of high-tech jobs, and then our suppliers are going to come in behind us. And so we're very grateful for that. We also have a couple rounds of contracts with the U.S. Air Force that wants overture for kind of government and defense applications. So there's investor capital plus government capital. And then the best of the capital is customer capital. And like I said, we've already gotten our first non-refundable deposits, and we expect those to continue to ramp higher over time, and ultimately be the most important source of working capital.
That's super exciting. And one of the big questions I think that people are wondering is, what are the first routes going to be?
Yeah.
Like when can we ride on Overture?
Our goal is to be able to carry passengers around the end of the decade. So we're 3-4 years into a roughly 10-year journey on that. And first routes, it'll really be up to our customers. Concorde was famous for New York, London. And Overture will be, to paint the picture on that route, imagine leaving New York in the morning, even with the time difference working against you, making a late afternoon meeting in London, and going out to dinner and then being home that same night to tuck your kids into bed. That's the kind of thing that Overture makes possible. And then being able to do that at more like a business class kind of affair versus like a $20,000 Concorde ticket. So that's one example, but the neat thing is it's not just that route. There are over 600 routes that have the volume of passengers and the economics to support this. So not just New York to London, but Miami to Madrid and Washington, D.C. to Paris. You can do a really neat shuttle between Hong Kong and Tokyo. From the Middle East, you can be in London in time for the opening bell of the stock market while having slept in about 2 hours longer. So there are stories like that all over the planet, and the ones I find most compelling are it's not just about saving a couple hours on the flight, like one less movie or a little bit less email. It's about what changes what you can do in a day, what changes what you can do in a week. Like if I'm leaving the US and I've got a Monday morning meeting in Tokyo, today I have to leave midday Saturday, 12 hours later I get to Tokyo, it's end of day Sunday, I go to my hotel room, I try to sleep, my alarm goes off the next morning, I get up and try not to sleep in my meeting, and I go back home at the end. It takes 3 calendar days, and then I'm messed up from the jet lag from the rest of the week. And aboard Overture, you sleep at home Saturday night, Sunday morning you get on a flight, an 8 a.m. departure from San Francisco Sunday morning, gets there 8 a.m. Monday morning Tokyo time. To us, it's Sunday afternoon, we're awake, the Japanese are awake. We could do a whole day of meetings, catch an overnight flight back. We're back in the U.S. 24 hours after we left with no jet lag because we never had to change time zones. And so that's the kind of thing that, like, in my mind shows, how transformative the speed is. The best analogs we can find in history for this are what happened when we went from props to jets in the 1960s. About 80% of the flying that happened on jets was not people upgrading from props. It's flying that would not have happened at all otherwise. Like Hawaii was not a tourist destination before the speed of the jet. You just go, where do you go from the West Coast US? I don't know, Napa Valley. But when you get to Honolulu in 7-8 hours, all of a sudden an island vacation is possible. Well, think forward to supersonic. Now Sydney is going to be as accessible from the US as Honolulu is today. And when I start to think about the second order effects of that, where we vacation, where we do business, even who we can fall in love with, I get incredibly excited.
I love that concept, and one of the things is with age, you quickly determine that it's not the distance that you fly, it's how long it takes you to get there.
Yeah.
And even the evening flights where you can get to bed makes a world of difference. So, but at the same time, it's like one of the concerns which I think we discussed often is I mean, there's obviously a financial and environmental cost to this. And I think one of the interesting things is you've mitigated this by making the plane 100% compatible with SAF, with sustainable fuels. I mean, can you discuss a bit about that and how that's going to change?
Well, if I start with why, ultimately I believe conversations like the one you and I are having right now are so much better in the same room versus when we did this over Zoom. But why do people not connect in person? It's because flights are too long, too expensive, too inconvenient, and then we've got real questions about the impact on the planet. And so those are the four things that we need to innovate on over decades to come: speed, affordability, convenience, and sustainability. And so with Overture 1, the efficiency improvements take us from what would be like a multiple of first class kind of fare on Concorde for a not very comfortable seat to something that's very profitable for airlines at about a quarter of that. More like a business class kind of fare. And then, but bring it over to the climate piece of this. Supersonic airplanes are inherently more energy intensive. So getting the energy in the cleanest way possible and the most economic way possible really matters. And so we look at this really carefully, and where we wanted to, how we wanted to approach it. And we made the choice to design around sustainable aviation fuel, or SAF. And if you don't know what SAF is, it's basically synthetic jet fuel. And the first couple generations of it were biofuels based or waste oil based, and they had cost issues and they had scalability issues. But there's an emerging third generation of SAF that's called power to liquid. That basically starts with a carbon source. Ultimately, it'll be an atmospheric carbon source, and combines that with low-cost green electricity to create an ultra-pure synthetic fuel. And so today's airliners can take 50-50 blends of SAF and the old stuff, and we designed Overture and the engine Symphony to be able to run on 100% sustainable fuel. In that context, there's actually climate advantage in supersonic. So if you're running on advanced SAF, the carbon impact would actually be less supersonic than it would be flying on a subsonic airplane, even though it's more energy intensive. But we think a lot about that, about how to minimize the negatives, and how to also make sure we're using energy sources that are scalable and cost effective, because ultimately we want to make this airplane available to everybody who flies.
Absolutely, and of course, like just so people understand, like you're being very pragmatic about this. So you've only picked the routes which are over water, because at the end of the day, sonic booms are sonic booms, and it's for now not solved. We've seen NASA with the X-59.
Yeah.
Are you going to be able to implement some of that research if you're doing there in your later models?
Well, I'll start with product philosophy a little bit, because you touched on that, and then we can go to the supersonic over land piece. Like Overture is, to use Silicon Valley parlance, the minimum viable supersonic jet. And so one of the key things was figuring out kind of where to start, such that we don't have to solve all the problems. So we picked the right amount of range, more like 4,000 miles, less like 8,000 miles. We picked the right size airplane, 64 passengers in all business class, not yet trying to do a supersonic jumbo. And then being able to double the speed of today's airplanes out over open ocean, where there's no question of a sonic boom because there's no one there to hear it, and then flying about 20% faster right under the speed of sound over land. So there's a bunch of pragmatic kind of product choices there that still allow a very large market even for the very first airplane. And then of course once you can get from Tokyo to Seattle in 4.5 hours, but actually crossing the US is longer, there's going to be a lot of appetite for how do we have supersonic flight everywhere, and that's something that we plan to address in Product 2, Product 3, and I think it's very attainable to do that. It's just not part of where we start.
You've had some of the toughest challenges. Most people would say you're never going to get a plane off the ground. We're here today there's a plane sitting right behind us that's going to fly in a few days, potentially. What's your advice to other entrepreneurs? Like, how did you get through those nights where you're like, why am I doing this?
This is going to sound surprising. My first company was a barcode scanning game, and my personal experience of that was it was much harder than building Boom. And that probably sounds crazy, but let me see if I can bring people into it. Every startup has challenges. And when I was working on the first one, I would sometimes get up in the morning and think, why in the world did I get myself into this? And I would just want out. As it's like this here's some existential crisis, and like, is it even frickin' worth it? And one of the reasons I decided to go do Boom is I never wanted to ask that question. No matter how, every startup is going to be hard, and any ambitious founder is going to be running at their personal red line, and running at the personal red line, dealing with I don't know how we're going to get through this one, and followed by I don't know how we're going to get through the next one. It's going to feel the same, but what doesn't feel the same is it fucking worth it? And so I think there's actually this almost like Moneyball type advantage in picking the more ambitious mission, because we've got our challenges, but I've never thought, is it worth it? And and on day zero, when I was like sort of wrestling with like, do I even try? Would I rather try and fail, or would I rather spend the rest of my life wondering what if I tried? And and I thought about the entrepreneurs that I really admire. The Steve Jobses and the Bill Gates, and back in the day, the Thomas Edisons, who have built things that people said were impossible to build. And I think of Gates having said, he was going to go put a computer on every desk and in every home, and he said that at a time that was crazy, and then he achieved all that and then some. And the people who set out to do ambitious things and they succeed, we know their names, we know who they are. And the people who try and they don't make it, we don't know their names, but they know they tried. And I would much rather be the one that tried and didn't make it than the one who never tried. And the sort of surreal thing for me 10 years into this is it's kind of working. We've with this airplane behind me is the first supersonic jet ever built outside of a government and a military. And when it takes to the skies in a few days, it'll be the first civil supersonic jet to have flown in more than 2 decades since Concorde shut down. And we've got tens of billions in orders and pre-orders from some of the best airlines on the planet. Like we got all kinds of things to overcome in the future, but we've already done some things that we didn't know if we could do, and that's what buoys me for the future.
Okay, so as a tech investor, I think the thing that impressed me most, and I think what most people don't realize about Boom, is you've managed to convince, I'm looking at your head engineer, you've got the guys that basically built all the recent Gulfstream aircraft successfully, which in itself is absolutely incredible. You've lined up all the best suppliers. That couldn't have been easy. I don't think that a lot of people who aren't entrepreneurs would understand that that's nearly impossible, yet you've done it. Like, how were you able to do that?
The fundamental thing is having a plan that actually makes sense, that stands up to scrutiny, and then executing on that plan and building momentum. And that was back part of the strategy of XB1, which was built with a team really out of the experimental aircraft kind of world. A lot of people who had worked with Burt Rutan at Scale Composites, people from SpaceX, and then when we wanted to go start the Overture program, we wanted to get a team that had built a Part 25 transport certified aircraft before. And I remember when I talked to the guy who became our chief development officer, who had been chief engineer on the G650 at Gulfstream, I could tell he wanted to believe, but he wasn't totally sure. And so he came out to Denver, and at that point, this airplane was it was kind of pieces, on the hangar floor, not yet assembled. And I remember watching Brian as he stuck his head inside the fuselage. He turns back, he looks at me, he smiles, and he says, "That's a real airplane." And so that ability to show that we're really doing it to people who know what that looks like is fundamental. And so Brian came on board, and then we started doing the same thing with suppliers, and we spiraled up. And the more people who joined the team, the more people who wanted to join the team, and I mean both supplier team as well as employee team. But the fundamental is we are actually executing a pragmatic plan to build a supersonic airliner. And when you look at it closely, that's what everybody sees. And when they see that, they want to be part of it, because that's the future.
Blake, thank you so much for your time. It's been incredibly insightful. And it's really great to see entrepreneurs like you doing what you do and knowing how difficult it is. And thank you, because without entrepreneurs like you, we really wouldn't be pushing the limits, and we wouldn't be having supersonic flights or doing the amazing things that humans do. And it really, I think that it brings the species, well, one level up. So thank you for that.
I appreciate your saying that, Phil, and honestly, right back at you. It's not just a bold company requires bold backers, and people who are willing to think for themselves and look past conventional wisdom. And you and your team have done that. We're very grateful.
Thank you. It means a lot. A few days after this interview, on March 22nd, 2024, Blake and the Boom Supersonic team made aviation history as the XB-1 took flight and landed safely, the first privately owned supersonic jet company to do so.